All right, so let's continue here with video 2 on parallel and perpendicular lines. So, example 3. So it says, what is the equation of the line that passes through the point 1, 7 and is perpendicular to the graph of y equals negative 1/4 x plus 11? So if we take a look here, right, we are going to have to identify a point and a slope in order to use point-slope form, and then we'll get it into what's called slope-intercept form. But in this problem, they give us a point, 1, 7. This is going to be our x1, y1 in point-slope form. Now, if we want the line perpendicular to this graph, we have to grab the slope from this line. The slope here is next to the x. Again, this is mx. So m is negative 1/4. We need the opposite reciprocal to negative 1/4. Our slope is going to be a positive number, and we're going to flip the 1/4 upside down to make it 4/1. And positive 4/1 is just 4. This is our opposite reciprocal slope. That is what we're going to use for our equation. So we use point slope form. So y minus 7 equals m4, parenthesis x minus x1, and x1 is 1. And now we're going to put this in slope-intercept form. 2 steps. We're going to multiply the 4 to the x and the 1, distribute. So y minus 7 equals 4 times x is 4x. 4 times negative 1 is negative 4. And then to get y by itself, we're going to add 7 to both sides. The y's come down, the y comes down, the 7's cancel. Equals comes down, 4x comes down, and again use Desmos negative. 4 plus 7 is positive 3. And there's our equation of a line perpendicular to that line through the point 1, 7. Cool. All right, next are the graphs of the equations 3y equals negative 4x plus 6 and y equals negative 3/4 x minus 5. Parallel, perpendicular, or neither. So in order to determine their relationship, we need to find the slopes. So let's take a look at the first equation. 3y equals negative 4x plus 6. This is not quite in slope-intercept form. It's very close. We just have to get y by itself by dividing by 3. And we'll do it 3 times. Once, twice, 3 times. Y's cancel, 3's cancel, y comes down. Negative 4/3 doesn't simplify, it's just negative 4/3. X comes after. Positive 6 divided by 3 is positive 2. So from this equation, we have a slope of negative 4/3. So now we're going to take a look at the second equation. This second equation is actually already in slope-intercept form. We're pretty lucky. Now the reason it's good to go into slope-intercept form because slope-intercept form identifies the slope. So this slope already is negative 3/4. And now we compare. How does negative 4/3 compare to 3/4? Well, they are definitely reciprocals, 4/3, 3/4. But notice that they're both negative. They're not opposite reciprocals. So these two slopes are not equal. So that means they're not parallel. They're not opposite reciprocals. Opposite reciprocals. They are reciprocals, but they're not opposite reciprocals. And because they're neither of those two, then that means their relationship is neither parallel nor perpendicular. They are neither. So there's a pretty good example of comparing slopes. Okay, and last but not least, a little word problem here to have some fun with. So it says, a landscaper plans to install 2 new paths in a park. The new fountain path will be perpendicular to the east path and lead to the fountain. The new picnic path will be parallel to the fountain path and pass through the picnic area. What are the equations in point-slope form that represent the new paths? Okay, so they kind of bail us out here. Point-slope form, not too bad. We won't have to do a lot of simplifying. Okay, so let's talk about the first one. So we're looking at the fountain path, and we know that it has to be perpendicular to the east path. So over here, I'm first going to look at the east path. Okay, the east path. Right here, it's this red line, right? So it looks like it has a y-intercept at 0, 2. And if I count the slope rise and run, it looks like it goes up 1 and right 1, 2, 3, 4, 5 to get to the next point. Up 1, right 5. So the east path has a y-intercept of 0, 2 and a slope of up 1, right 5. Okay, I don't need the equation of the east path, I just need to know that information. Okay, so now let's turn to blue and let's go with our fountain. So we want to find the equation of the fountain path. So for the fountain, well, it's going to be perpendicular to the east path, and it's going to lead to the fountain. So it's going to be perpendicular to the east path and lead to the fountain like this. It's going to look something like this. There's my fountain path, right? Perpendicular through the fountain. Well, I need to know the coordinates of the fountain. The fountain here is at 15, 2. And if it's perpendicular to the east path, its slope will be the opposite reciprocal of the east path's slope. So the point that I know for the east path is 15, 2, and its slope is going to be the opposite reciprocal of 1/5. That'd be negative 5 over 1, or negative 5. So again, that came directly from that slope. So now point slope form for the fountain. Y minus y1, y minus 2 equals m negative 5 times x minus x1 is 15. And that would be the equation of the fountain in point slope form. And I'll turn to, let's do green, right? And now let's take a look at the new picnic path. The new picnic path is going to be parallel to the fountain path and pass through the picnic area. So now, if this, and if I continue the fountain path, if this is the fountain path, the picnic path will be something like this, parallel to the fountain path. So it's going to have the same slope as the fountain path, but it has the path through the picnic area. So the picnic area here is at the coordinates of 5, 6. So over here for picnic, and I'll do it down here. So I know the coordinates are 5, 6. And if it has to be parallel to the fountain path, it has the same slope as the fountain path. The fountain path slope was negative 5, so this slope is also going to be negative 5. Comes directly from there. So your point slope form y minus y1, which is 6, equals m, the negative 5, times x minus x1, which was 5. And that is the equation of the picnic path. All right, there we go. Okay, so that is your parallel and perpendicular lines. Thanks for watching and good luck.